Again, welcome to DSRT 734 class. In these lectures, we're going to cover the frequency distributions and their graphs. Our main objective is to learn how to construct a frequency distributions, also how to construct frequency histograms, frequency polygons, and relative frequency histogram. So we start with what is a frequency distribution. Here we say the frequency distribution is a representation either in a graphical or tabular format. And we will start with the tabular format first. That displays the number of observations within a given interval. So the interval size depends on the data being analyzed and also the goals of the analysis. The intervals must be mutually exclusive and also exhaustive. We shall explain what we mean by that. So for example, here we have a frequency distribution with two columns, the class, which is the interval. So we can see that this interval from 1 to 5, we move from 6 to 10, 11 to 15. The class width is the same, but we make sure that 5 can only appear in one interval. So this is the concept of, again, mutually exclusive. We don't want from 1 to 5, then from 5 to 10, which means 5 can appear in two rows. We don't want that. So here we say a table that shows the classes or intervals of a data within a count of the number of entry in each class. It's the frequency distribution. And also the frequency F of the class is the number of data entries in that class. So maybe you have a data set, and within class from 1 to 5, we have total tally of 5 observations. Now, between 6 to 10, we have 8 observations. So we call, again, the section as a lower class limit. Then we have the upper class limit. Now, the difference of the lower class limit and upper class limit must be the same, 5. So we have 6 minus 1, 5. Also 11 minus 6 will give me 5, and 16 minus 11 will also give me 5. So this tells us that, again, the class width is the same. Now, how do we construct a frequency distribution? First of all, we have to decide, and let's go back, we have to decide how many class or intervals we need. Now, it depends on the size of the data set, how many observations we have, and also the values, the range of the values. Here, the range of our classes values, let's say from 1 to 30. So we can start our class with the minimum value. And based on the size of the value, we may decide how many classes or intervals we need. So here we said usually we need somewhere between 5 to 20. So if we have a question and they say we should construct a frequency distribution, if the number of classes is not given, then we have to decide somewhere between 5 to 20, the number of the classes. And otherwise, it may be difficult to detect any patterns. So this means if we have lower class, let's say we have only, in this term, let's say we have only 2 classes. Let's say from 1 to 20, or from 1 to 15, and 16 to 30. In this case, we are not going to see too much pattern in the data because they are all going to be only in 2 classes. So again, here we say between 5 to 20 is fine. Otherwise, it may be difficult to detect any patterns in the data. The data cannot be spread out so that we can detect any pattern. So first thing we do, again, decide on the number of classes. Now, if we know the number of classes, then we can find the class width. So the class width will be determined by the range of the data. The range of the data will be the difference between the minimum and the maximum value. Then we divide the range of the data by the number of classes that we decided in the first step. So to find the class width, it will be, actually we're going to do an example soon. So normally to find the class width, it will be the maximum value minus the minus the minimum value divided by the total number of classes we have. Again, we will do an example. So the next step is to find the class limit. Here we can use the minimum data entry. And when we look at our data set, the minimum value, we can start that as our lower limit of the first class. Then find the remaining lower limit by, we already find the class width. So now to find the next minimum data entry, we find again, we add the class width to the lower limit of the preceding class. So if the lower limit is 5 and the class width is 10, then the next class interval, the lower limit also will be the width plus the previous class. Then we also find the upper limit of the first class. We should remember that the classes cannot overlap. This is the concept of, again, exclusive. We may discuss this more detail later on. Then we find the remaining upper class limit. Now we have to so we finish with the class interval. Again, the best way to understand this is by doing an example, and we shall go through an example soon. So next we make a tally mark for each data entry. This will be our second column, which will be the frequency. So we count the tally marks to find the total frequency for each class. So this will be the best way to, again, learn this concept. So here we are given a data set. This data set consists of 50 internet subscribers, the time they spent. So here the following sample data set lists the number of minutes 50 internet subscribers spent on the internet during their most recent section. Now the question says we should construct a frequency distribution that has 7 classes. So here the number of classes is given to us. Now this is our data set. As we said earlier, we use the frequency distribution to organize our data. Because now if I said, okay, I'm looking for subscribers who use less than 30 minutes, which means I have to go through all the lists. Or who use 50 minutes, I have to go through all the lists and count it. We don't want to waste time on that. So we are going to organize our data, and it will be more easy again to answer any questions about the data. We also can find a pattern in the data. For example, we can say that most customers use between 50 to 60 minutes, or few customers use less than 10 minutes. So the previous steps that we follow, we are going to start. Step 1 is already given to us. The number of classes we need is 7. It's already given. So if I know the number of classes, we can find the range. To find the class width, first we find the range. The range will be the maximum value minus the minimum value. So in the data set, 86 is the maximum value and 7 is the minimum value. Then we divide by the number of classes. So this will give us the class width. Now the class width, when we get the answer and our answer is in a decimal, we have to run it up. So for example, what we mean by run up, it means if I have 11.1, I'll make it 12. If I have it 11.9, I'll still make it 12. We are not going to approximate it, always run it up. If I have 10.3, I'll make it 11. So now we have our class width to be 12. Okay, so if we know our class width is 12, then the next step, we are going to use the 7, which is the minimum value, to start our lower limit. So if our first lower limit, based on the data set, 7 is the minimum value, then the next lower limit, we are going to add the class width. Then we're going to do that until we get the 7 classes. So here we get 31, 43, 55, 67, 90. The difference between all this data interval is 12. Now, since we know that we cannot have two values in, or a one value in two rows. There shouldn't be any overlay. So in this case, we are going to again make sure if I move from 7 to 19, it means I should go from 7 to 18. Then 31, so I'll go from 19 to 30. So our upper limit against 18, then the next will be 30, because we have 31 here. We have 43 here, so the next will be 42, then 54, 66, 78, and 90. Here we make sure that each value can only appear in one row, not more than one. So now we have the lower limit. We also have the upper limit. So we get our first column of the frequency distribution, which is the class interval. So this is our class interval now. The next step, we look at our data set, and we are going to count how many subscribers spent between 7 to 18 minutes. And when we count, we have 6. Between 19 to 30, we have 10. 31 to 42, we have 13. 43 to 54, we have 8. And 79 to 90, we have 2. Now, the total frequency should give us the total data set. Since we said one person cannot be, or one value cannot be in two rows, each have to be unique. So this will be our frequency distribution with only the class, interval, and the frequency. Now, next step, we can include the relative frequency. Relative frequency will give us the proportion, or we can even say the percentage of the number of data that appear in each class. So next, we learn how to find the midpoint of a class. So a midpoint of a class is the lower class limit plus the upper class limit divided by 2. So it will be 7 plus 18 divided by 2. Then 19 plus 30 divided by 2, and 31 plus 42 divided by 2. So our midpoint of a class will be 12.5, 24.5, and 36.5. Now, next, we are going to learn how to determine the relative frequency. As we said earlier, the relative frequency is more or less like finding the proportion of each class category. So relative frequency will be the frequency of each class divided by the sample size, or the total frequency. So from 7 to 18, our frequency is 6, and the total data set is 50. So the relative frequency between 7 to 18 will be 6 divided by 50. From 19 to 30 minutes, it will be 10 divided by 50, because we have 10 frequency. Then from 31 to 42, we have 13, so it will be 13 divided by 50. Now, if we find the relative frequency for all the class category, if we add all together, we will get 1. Next, we can also find the cumulative frequency. The key word is cumulative. So when we get the frequency of the first class interval, we are going to add it to the second class interval frequency. So we are going to add, so at the end, the last cumulative frequency class interval will be 1, because we are adding the previous. So first, let's find the cumulative frequency, then we are going to find the relative cumulative frequency. So cumulative frequency will give the total cumulative frequency will be the 50, because we're going to add the previous. So for example, we have 6 here, the next will be 16, then 16 plus 13, I think should be 29, then we keep going. So we had the 10, we have 16, then we have 29. And when we do this to the end, this is the cumulative frequency. We'll see that the last value will be 50, because we are adding the previous frequency to the current frequency. Now, as we said, we can also find the relative frequency. So relative frequency, again, will be the previous, each category. So we have 6 divided by 50, 10 divided by 50, 13 divided by 50. And when we add all the relative frequency, we will get 1. So this is, again, frequency distribution table. The first column is the class interval. The second column is the frequency. That is the total tally in each class category. Then we find the midpoint. The midpoint will be important when we drawing, for example, the polygon or the histogram concept, which we will come to that. Then we have the relative frequency. Then we have the cumulative frequency. So next is the frequency histogram. A frequency histogram is a bar graph that represents the frequency distribution. So we can see the x-axis will be our data values, which normally will be the class category. And vertically will be the frequency, or the vertical line will be the frequency. So it's like we are using a frequency distribution table, the 2 columns for the class, which will be the x-axis, and then the frequency will be the vertical axis. Now, the horizontal scale is again always quantitative and measures the data values. Then the vertical scale also measures the frequency of the classes. Then we also have the consecutive bars must touch, as we can see, the next batch or the previous bars bar must touch the next bar. And each bar must touch each other. Now with a column chart, the bar doesn't touch each other. So first we're going to find what we call the class boundaries. And the class boundaries is the numbers that separate the classes without forming gaps between them. So how do we find it? It will be the distance from the upper limit of the first class, in this case is 18, to the lower limit of the second class. So it will be 18 and 19. So the difference of 18 and 19 will give us 1. Then half this distance will be 0.5. So here the class boundary, when we get the 0.5, we are going to subtract it from the lower limit. So 0.5 from 7 will give me 6.5. Then I'm going to add 0.5 to the higher limit, which will be 18 plus 0.5. So here we say the first class lower boundary will be 7 minus 0.5, which will give us 6.5. Then the first class upper boundary will give us 18 plus 0.5, which will be 18.5. So same thing we have to do. So with the next 19 will give us 18.5, and 30 will give us 30.5. So 18.5, 30.5, 31 will give us 30.5, 42 will give us 42.5. And this will be the class boundary. So again, to find the class boundary, we find the difference between 19 and 18. It can even be 30 and 31. The difference will always be 1, since the class width interval are the same. Then we divide by 2. So that gives us 0.5. Now we remove 0.5 from the lower limit, and we add 0.5 to the higher limit section. So that gives us 6.5 to 18.5. Our frequency will remain the same. Now the next is the midpoint. We included the midpoint, which we calculated previously. How do we get the midpoint? Let's say 12.5. We had 7 plus 18. Then we divide again by 2. So 7 plus 18 will give me 25. 25 divided by 2 will give me 12.5. 19 plus 30 will give me 49. 49 divided by 2 will give me 24.5. And we do that again. So always we had the upper and the lower limits and divide by 2. So now we can have our frequency histogram using the midpoints. So we can see the midpoint 12.5 in the middle, 24.5, 36.5, etc. And also based on the frequency, for example, when we go back 12.5, let's go back. In 12.5, the frequency is 6. 24.5, the frequency is 10. And the bar will be between 19 to 30. So, or the midpoint or so value, 24.5. So that's why here we have 10 because the frequency is 10. Again, with the histogram, the vertical line is the frequency. So then the horizontal line will be the interval, the class interval. The class interval again is based on minutes. Here we are using the midpoint, but we start from the lower limit also for the first class. So that's the internet again usage, the time online, and also the frequency vertical line. So here we can see that more than half of the subscribers spent between 19 and 54 minutes on the internet during their most recent section. So that's one of the advantage of frequency distribution table or histogram. We can see the pattern of the data very easy. Next is how to graph what we call the frequency polygon. But a frequency polygon, again, is a line graph that emphasizes the continuous change in frequency. So example is what we have here. We have the data values and the frequency, and we are going to use the midpoint values to construct it. So let's see this example again. Here they say we should construct a frequency polygon for the internet usage frequency distribution. We know the classes, we know the midpoint, and we know the frequency. So here we can see that we start from 0.5. Then we move on to 12.5, then 24.5. So those are again the midpoint. Let's go back. The midpoint 12.5, 24.5, etc. And also we should be careful the frequency. We know 12.5, the frequency is 6. So we have a point there. 24.5, the frequency is 10. So that point. Then later we join the point with the line. So here we said graph should begin and end on the horizontal axis. So extend the left side to one class width before the first class midpoint, and extend the right side to one class width after the last class midpoint. And here we can see that the frequency of the subscribers increases up to 36.5. Then after 36.5, it starts to decrease. Next is how to graph again relative frequency histogram. A relative frequency histogram has a same shape and also is the same horizontal scale as corresponds to the frequency histogram. So this is an histogram. The horizontal will be our class interval values, but this time, instead of using the frequency values, we are going to use the relative frequency. So kind of the shape will be the same as histogram. So the vertical scale measures the relative frequency instead of the frequency. So here we have our relative frequency. We have our classes. So now we can construct. So we can see our relative frequency from 0 all the way to 0.3. So based on the data, we can see that in our relative frequency, the highest value is 0.26. So we do our scaling from 0 to 0.3. Then we have again, the same class interval down. So we can use our class boundary concept. So next is the cumulative frequency graph. So the keyword again is cumulative. So it will be increasing throughout. So that will be the shape of because we had a previous frequency to the present. So at the end, we are going to get 50. So let's see the example again. Here they say we should construct a frequency distribution that include the cumulative frequencies as one of the columns. So first thing we need to do is specify the horizontal and also the vertical scales. Normally, the horizontal scale will consist of the upper class boundaries. Then the vertical scale will measure the cumulative frequency instead of frequency. And then we plot the points that represent the upper class boundaries and also their corresponding cumulative frequency. Then we connect the points in order from left to right. So the graph should start at the lower boundary of the first class. Then it will increase. Cumulative frequency is 0 from beginning. Then it should end at the upper boundary of the class. So this example again, we are using the same table. We have our cumulative frequency, we have our class, and also the class boundary. We want to construct this graph. So we can see that again, we start from 6.5, 18.5, we are increasing until we reach the highest. In this case, is 50 cumulative frequency. Our total data set is 50, so it won't go more than 50. So here we can see that from this graph, you can see that 40 subscribers spend 60 minutes. Because when we reach 40 subscribers somewhere here, we can see that they spend around 50, 60 minutes or less, because 65 is more than 40 subscribers. Then the greatest increase in usage occurred between 30.5 and 42, because we can see the steepness of this short line from 30.5 to 42.5 is very steep, very increasing. So that will be the conclusion of our lectures. Again, these lectures will learn how to construct frequency distribution table. We also explain what it means, and also different types of graphs such as polygon, histogram, etc. So see you in the next class. Thank you.